Good morning. Now we are going to solve practice problem 3.13 from Fundamentals of Electric Circuit by Alexander Sadiku, 5th edition. So it is a transistor circuit again, and the transistor circuit has beta as 80 and VB as 0.7 volts. We are asked to find out V0 and I0. Okay. So this is the I0 and this is your V0. So this is your input side, and so for the input side, if you look at it, we can apply the KVL. Okay, so for this we can apply KVL, but for the output side at this node we are going to apply the KCL. So it starts from here and then it is following this path, -1 volt plus 120 kilo ohm, so it is 10 power 3 resistance into current IB. Okay, so this base to emitter voltage is VBE, so that is equal to 0. So it is -1 plus 120 into 10 power 3 IB plus VB is 0.7 volts, it is equal to 0. So when you add these two, -1 and this one, we get it as -0.3. -0.3 plus 120 into 10 power 3 IB is equal to 0. So 120 to 10 power 3 IB is equal to 0.3. Then IB is equal to 0.3 divided by 120 into 10 power 3. Okay, so this IB is equal to the 0.0025 into 10 power minus 3, 2.5 microamps. So at the output side, we are going to apply KCL at this particular node. The total current I is equal to I0 current plus IC current. 20 minus V0 divided by that 10 kilo ohm. So 10 into 10 power 3. Then I0, V0 minus 0 potential divided by the resistance. Okay. So it is 10 kilo ohm. So 10 into 10 power 3 plus IC. IC, that is nothing but beta times IB. Like that we can write. Okay. So here it is 20 minus V0 divided by 10 power 4, that is equal to V0 divided by 10 power 4 plus is given in the problem as 80 into IB. We have found it as 2.5 into 10 power minus 6 because it is 2.5 microamps. In order to cancel this out, I am going to multiply and divide this by 10 power 4. Okay, so that I can cancel out these terms. So here I get it as 20 minus V0, that is equal to V0 plus this 2 minus 2, right? Okay, so 80 into 2.5 into 10 power minus 2. So it is minus V0, that is equal to minus 20. If you bring this 20 to this side, minus 20 plus 80 into 2.5 into 10 power minus 2. So it is minus 2 V0, that is equal to minus 20 plus this value. It is 200 into 10 power minus 2, that means it is 2, right? So it is minus 20 plus 2, so it is minus 18. So minus 2 V0 is minus 18. In the sense we can write it as V0 is equal to 9. And we have to find out I0, right? So if you check the problem here, I0 is the current which is flowing through this 10 kilo ohm resistance, and the voltage across this one is V naught, right? So V naught we have found out that as 9 volts. So I naught is equal to V by R, right? So it is V naught by that resistance R naught. Okay. So it is 9 divided by 10 kilo ohm. So 10 into 10 power 3. So that is equal to 0.9 into 10 power minus 3. So it is zero point 0.9 milliamps. So I naught is 0.9 milliamps. This is the answer we got.